Welcome to Understand the Math. In this video, I'm going to teach you how to factor quadratic functions. We'll start with some basics, and then I'll teach you how to factor quadratic functions that have a 1 in front of the x squared term. And then we'll look at factoring some more complicated quadratics where we have a constant that's not equal to 1 in front of the x squared term. These are harder, but I'll make it easy by giving you some clear steps that you can follow. Let's begin by learning what a quadratic function looks like when it's in factored form. Just as a review, a quadratic function is a polynomial that can be written in this form. F of x is equal to ax squared plus bx plus c. A, b, and c are all real numbers, and a is not equal to 0. When we factor a quadratic function, we're just going to rewrite it as a product of two binomials. If there's a 1 in front of the x squared term, the factored form of our quadratic is going to look like this. And then if there's a number multiplying the x squared, the factored form of our quadratic is going to look like this. Don't worry, you don't need to memorize this. I just wanted to give you an idea of what the factored form looks like. The factored form of a quadratic is really useful when you solve equations, when you find zeros, and then when you graph the quadratic function. Let's now walk through some example problems. The first two examples that we're going to do are when we have a 1 that multiplies the x squared term. Here's the function that we're going to factor. I wrote down 3 steps that you can follow when solving these types of problems. And we'll go through these steps one by one as we solve the problem. Let's go ahead and let's look at our first step. The first step says that we're going to find two numbers that multiply to get the constant term. The constant term in our problem is equal to 12. So I'm just going to put 12 so we can remember that. Now we want to find two numbers that multiply to get 12. I'm going to be really systematic with this, and I'm always going to start with 1. So the first two numbers that multiply to get 12 would be 1 and 12. And then we'll go to 2. 2 goes into 12. So the two numbers would be 2 and 6. And then we'll go to 3. 3 goes into 12. And we have 3 and 4. And then once we get to 4, everything starts repeating and we would get like a 4 and a 3. So we can stop there and go on to our second step. Our second step says that from these numbers that we've just wrote down, we want to find two of them that add up to get the coefficient of the x term. So let's go back up to our problem. The coefficient in front of the x is equal to 7. So I'm going to write that down right here. So when we look at these numbers, and these numbers, we need to figure out which of those pairs add up to equal 7. And you can see that it's going to be 3 and 4 because 3 plus 4 is equal to 7. Let's now highlight 3 and 4 because those are the numbers that are going to appear in our factored form. Our step 3 says that we're now going to write the quadratic in factored form using these two numbers. We have x squared plus 7x plus 12, and it's going to equal x plus 3, and then x plus 4. And that is our final answer. It's our quadratic written in factored form. Let's now look at another example. This example is really similar to the one that we just did on the previous page, but notice that our constant term has a negative, and that's going to make things just a little bit harder. We're going to do just like we did. We're going to start with our first step, and we're going to find two numbers that multiply to get this constant term. So let's write down our constant term is minus 18. And we have to write down two numbers that multiply to get this number. We're again going to be systematic and we're going to start with 1. So I'm going to write down 1 and minus 18 because it's negative. And then to the right, I'm going to write down minus 1 and 18 because both of those numbers multiply to get minus 18. Now let's go to 2 because 2 goes into 18. So we have 2 and minus 9. And then minus 2 and 9. Now let's try 3. 3 goes into 18, so we can write that down. So we have 3 and minus 6, or we have minus 3 and 6. And then if we go to 4, 5, those don't go into 18. And then we get to 6, and we already have 6. So we can go ahead and stop. And let's go to our second step. For the second step, we're going to look at all these numbers, and we're going to pick two numbers that add up to the coefficient of the x term. Let's go up here to our quadratic, and I'm going to highlight the x term. It's equal to 7. So let's write 7 down here. So we need to find from these groups of numbers, which of these numbers are going to add up to 7. And as you go through the list, you can see that it's going to be these two numbers right here, minus 2 and 9. So I'm just going to write down minus 2 plus 9 is equal to 7. You don't really need to write that down, but it's just a check to make sure that you pick the two right numbers. Now we go to the third step, and we can just write the quadratic in factored form using these two numbers. Our quadratic is x squared plus 7x minus 18, and it's equal to x minus 2 times x plus 9. You can always check your answer by multiplying these two expressions out and making sure that you get back x squared plus 7x minus 18. Now we're going to go on to our more complicated examples. And these examples are more complicated because the a that multiplies x squared is not equal to 1. You can see here that I have 6 steps that we can follow. I know it's a lot, but once you do a couple of these problems, you're really going to get the hang of it. We're going to go through these systematically, and we'll start with the first step. Our first step says to multiply a times c. Okay, so let's go up here and let's highlight. This is a, and this is c. So we can say that a times c is 2 times 3, which is equal to 6. Now let's go to our second step. Our second step says that we're going to find two numbers that multiply to get 6. That's just like we did in the previous examples. Let's go ahead and let's write down 6 right here so we know what we're working with. We want to find two numbers that we multiply to get 6. We're going to be systematic, and we'll start with 1. So we have 1 and 6, and then 2 goes into 6 3 times. So we have 2 and 3, and then 3 we've already taken care of. 4 and 5 don't go into 6, so we're done. Now let's go on to our third step. Our third step says that we're going to choose the two numbers from this group that add up to get b. Okay, so b, I'm going to highlight this in blue. That's our term that multiplies x. So we need to look at our list here and here and figure out which two numbers add up to get 7. So you can see really easily that they're going to be 1 and 6 because 1 plus 6 is equal to 7. I'm going to go ahead and highlight this so we know that those are the ones that we're working with. Now let's go to our fourth step. Our fourth step says that we're going to rewrite the middle term using these two numbers. Let me show you what this is going to look like. We'll start by writing down our quadratic, 2x squared plus 7x plus 3. And now we're going to take that middle term, which is 7x, and we're going to rewrite it. So we have 2x squared plus, we're going to rewrite it as an x and as a 6x. So plus x plus 6x, and then our 3 comes along for the ride. Now let's go to our next step. That's step 5. Step 5 says that we're going to group the first two terms together. Let me underline that. That's these two terms. And the last two terms together, and then we're going to factor them. This is equal to 2x squared plus x. I'm going to put parentheses around those because they're grouped together. And then we have a 6x plus 3. Now we're going to factor. If we look at the first group, we can see that there's an x common to both terms, so we can pull that out. And then we're left with a 2x plus 1. And then when we look at our second group, we can see that there is a 3 common to that. So we'll pull the 3 out and write that as 2x plus 1. Now we only have one more step. Step 6 says that we're going to factor out the common binomial. Let's go over here to the right. Notice that 2x plus 1 is common to both terms. So I'm going to factor that out. So we have a 2x plus 1. And then what's left is an x plus of 3. So we have x plus 3. And then that's it. That's our final answer. We have our quadratic in factored form. Let's do one more example just to make sure that you get the hang of this. I chose this example because the constant term is negative, and I think that makes the problem just a little bit more complicated. Let's go ahead and let's start walking through our steps. Our first step says that we're going to multiply a times c, so that's our first constant, 3, times our last constant, minus 8, and it's equal to minus 24. Step 2 then says we're going to take the number minus 24, and we're going to see what two numbers multiply to get this number. Again, let's be systematic. We're going to start with a 1. So we have 1 and minus 24. And then because we have a negative there, we can switch the negative, and the numbers minus 1 and 24 will also work. Going to give us a little bit more space. Now let's go to 2. So 2 goes into 24 12 times. So we have 2 and minus 12. And then minus 2 and 12. I'm sure you're getting the hang of this. Next, we're going to go to 3. 3 goes into 24 8 times. So we have 3 and minus 8. And then minus 3 and 8. And then our next number is 4. So 4 goes into 24 6 times. So we have 4 and minus 6. Or we have minus 4 and 6. And then 5 doesn't go in. 6 we've already done. And all the numbers after that we've already done. So we can stop and go on to our third step. So our third step says we're going to look at all these groups of numbers and we're going to figure out which two add up to get our middle term. So let's pull this back down. Our middle term, I'll highlight it here in pink so you can see, is a 10x. So we're going to pick the numbers that are going to add up to 10. So let me just put 10 here. So let's look at these groups. I'm going to go through these. Those don't work. The first 2 and minus 12 doesn't work, but look at this. Minus 2 and 12 definitely adds up to 10. So those are the ones we want to go with. So we have minus 2 plus 12 is equal to 10. Now let's go to our fourth step. We're going to rewrite the middle term using the numbers minus 2 and 12. So again, let's pull this back down. We have 3x squared plus 10x minus 8. 3x squared plus 10x minus 8 is equal to 3x squared. Now, this is our middle term. That's the one we're going to rewrite. So we're going to rewrite it as minus 2x plus 12x, and then the minus 8 comes along for the ride. Now let's go ahead and let's go to step 5. I want to go up here and I want to highlight step 5 so we can read that. We want to group the first two terms together and the last two terms together and factor. So let's go ahead and let's do that. This is going to be 3x squared minus 2x plus 12x minus 8. In our first group, you can see that we have an x common to both terms, so we'll pull that out. So we have an x, and then this is 3x minus 2, and then we have to find a term that's common to both 12 and 8, and that is going to be the constant 4. So we're going to pull out a 4, and that leaves us with 3x minus 2. Notice that we have the same term. So that's a really good sign that we've done stuff right. Now let's go on to our sixth step. So our last step says we just have to factor out the common binomial, and that's the one that I just underlined. So let's factor this out. We have a 3x minus 2, and then what we have left is an x and a 4. So we just multiply this times x plus 4. And that is our final answer. These types of problems can also be done by just looking at the numbers and trying to guess, but I know that frustrates students sometimes. And so I wanted to present this to you as a very logical way that kind of takes the guesswork out of having to factor quadratics. If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.